I wish you welcome to this presentation about experience with vortexes. I've been working on this since 1985, and I've done a bit. I would also thank the organizers for this beautiful conference to make us the opportunity to share our thoughts and findings. So, let's see. Yeah, this is me in my thinking mode. I represent first IET, which is the Institute of Ecological Technology in Sweden, which was founded by Olaf Alexandersson, the famous author of The Living Water, which got me and many others hooked on this subject. I also have a small company, Replicator, that works and sort of commercialize these ideas. And this is my email and my phone number if you want to contact me further on. So, I would like to make a statement that I am mostly the engineer, a bit scientist, but mostly the engineer. So my purpose in life now is to get all the findings we have seen, we have taught about, into some kind of reality, things that work outside there in the cruel world. And with that, I want to say also that my findings might not yet be scientifically proved, but it's observations and they work, they're operating. Also, Jerry mentioned all the water heroes in the beginning. I would like to add one more to this list, which is Viktor Schauberger, who is the person whose ideas and thoughts and work we have been inspired from. Also, something called nature. We have been studying nature, trying to find out how nature solves technical problems. This is very hyped today. Every university have an institute of biomimicry, or biomimetics. Schauberger talked about this in 1920s, and he said, "Die Natur kapieren und kopieren." Sorry for my bad German, but to understand and copy the nature. And it was 1920. Viktor Schauberger had a very, very strong personality, almost stubborn, I would say. He was a forester from the beginning, a nature lover. He thought that flowing water in the nature have a soul. And was certainly against the established science, so he was constantly fighting against them. He had his very own thoughts, terms, and theories. And he found out a dual operating principle in nature, how nature moves. And he called this implosion and explosion. Very, very quickly, implosion is a movement towards a center. It's a movement, kind of movement where the nature build up new life forms and gather energy. The opposite, the explosion, is when you have a dead animal is deteriorated in the nature, and its energy and its material is spread out to be used again. So therefore we call implosion life technology and explosion death technology. And it's meant that we are mainly using the death technology. Our cars is sort of literally explosive. So we caught some kind of imbalance in the nature if we use it too much. Today, the family Schauberger lives in Bad Ischl, Austria, and you can see the PKS, their villa up here. It's a very beautiful villa where they have a lot of conferences. We are working together with them. We have a conference in Sweden every odd year, and they have a conference in Bad Ischl every even year. And we also work together with Jörg Schauberger, the grandson of Viktor Schauberger. So, this is biomimetics put in practice, so to say. So what is it about? Well, we have these little things called DNA spiral. And if you go step up a level, you have an ordinary vortex in water. Could be a tornado as well. And then we look out in the universe to see some of the biggest objects we can observe. They all have one thing in common, namely the vortex movement. So we started to think, is Mother Nature trying to say us something? Why is Mother Nature using the vortex as some kind of a general design principle? Or can we use these insights to create a new kind of technology that is based on the nature and to create some technology that works better in the future with a better maintenance? So, or have you ever drunk tea or coffee? Here's the problem. There is a glass bowl filled with water and a lot of dirty stuff inside it. If you want to pick it out, if you want to clean the water, what should we do? I mean, you can pick them one by one, but it takes an awful lot of time. But you can also do like this. I'll start to stir the liquid, and look what's happening. And look the similarity between this and the spiral galaxies. Here we are again. This means that in this status, it's much more easier to pick the stuff out. It's coffee, used coffee ground. And 1994, we started to think we must do something out of this. We must make one of his things he made to make a replica to see we might get it to work. And this is one part of the famous trials in Stuttgart. We're trying to find out, does the vortex shapes on its own or does it need a bit of help? The answer was that the vortex is actually creating itself. It's a kind of a self-organization system. And also, what will happen to the stuff that goes down in that tube? Well, this is how it looks. What you see is still coffee. Our evil friend says to us that we have done nothing more than make a very big coffee machine. But we think different. So what you see is the coffee coming down. You have a vortex movement inside the tube. And it gathers together into this fine string. And then we have a small tube attached in the center. You apply a very little subpressure, and they link together. So you're actually able to pick out most of the stuff in the water through the tube. And what's coming out afterwards is more or less clean water. If you do it more times, you're sort of polishing the water. So then we invented or named something we call VPT. VPT stands for Vortex Process Technology. And the idea behind, as I said, is to study nature, how nature does when it do technical things. It's also fundamental in nature. We saw that you can find it almost everywhere, from our smallest things to the biggest things out there. And also, this biomimetic design allows us to harness the extreme power of a tornado for industrial applications. We just say it might be even able to use this with air. Suppose you can tame a tornado and extract the energy from that. Wouldn't that be cool? This is how it works. You have the water coming in from beneath. It meets this sharp point. It flows out in a torus-like form. It starts to circulate, it goes into the canals and goes out here. We have 5 canals, and together they shape a main vortex inside the vortex chamber. We have different sizes, different sort of designs for different purposes. In this case, the vortex comes out here and it goes backwards, creating a subpressure in the center. In this case, the subpressure is connected via a small tube up to the air. So this one is running underwater. So it's a very efficient way of mixing in oxygen or air into water. So you can mix a liquid with a liquid with a gas with a liquid, even a liquid with powder. And we use it for various purposes, which I will show you later. And it could also be used very effective to spray out things. In this case, to make ice on artificial ice arenas. And this is another type, a very early version that we put on the machine that goes around an ice when they're fixing it. And this is look underwater. where the bubbles coming out. You can see this little ring is a cavitation ring. The pressure is so low, so that actually the water is ripped apart. Then later on, we developed something we call the vortex system. We came in contact with Mr. Dan Rees from Texas, US. He had a problem. He wanted to remove iron and manganese out of drinking water. He had another system, but it didn't work very well. So we helped Dan to develop BOSI, and he has sold it in use since then. And this is how it works. Same thing, you have a nozzle up here, the water comes in, starts to spiral inside the tube, and the dirty stuff goes out in the center, and the clean stuff goes out into the next tube, and we repeat it for 5 times. But this is possible to remove around 50% of the iron, depending a little bit on how bad the water is, and almost 100% of the manganese. So that I would say it works with any kind of metal iron. Could be a solution for Fukushima, I don't know, maybe. We have just tested it with iron and manganese, probably other things as lead or whatever. And the reason it actually works so good is that it happened to be that the material was PVC. PVC is strongly electronegative. It wants to give away an electron. Now, the iron that comes in is positive. They want to have an electron. So when the iron is rubbed against the walls, they steal an electron. And after a while, you build up a very strong positive field. Could be around 200 to 300,000 volts. Meaning that next iron that comes in will be sort of repelled of that positive field. And it goes towards the center, where you have it, the weakest spot. And that's exactly where we want it, because then the vortex take over and suck it out. So this is also a typical way on how nature works. Nature works with many different ways to solve things, but they combine. That's why nature is so effective compared to our own systems. However, something funny happened. The plants grow better. We got reports from people using this stuff and watering the plants with our water. And they say, hey, they grow better. And we say, what the heck? And you can see we put up something called blomster pillars. And this one has been standing beside this one all the summer. This one was watered with ordinary tap water, and this one was watered with vortex water. And you can clearly see that there's a big difference between them. And also, they heal quicker. My friend Morten here is spraying water on a lemon tree that has some kind of disease, and it healed much faster than they expected it to do. So this gave us something to really think about, what's going on. And this also led us to make some bigger tests. We have made tests with soil penetration or wetting abilities and solubilities by farming in greenhouses, first in Dubai, where we tested with cucumbers, and in Olaf, Sweden. Olaf is a Swedish agricultural university just north of Malmö, with tomatoes. And the objective was actually to see if something happening, and then if what. And this is how it looked like in Dubai. Basically 2 barrels of water, 1 barrel with vortex water, 1 barrel without the vortex water. And this is how it looks at the end of the growing season. This one is with vortex water, and the other one is with non-vortex water. And the results was the crop grows slightly faster with vortex water, but the total yield when they harvest the crops was about plus 6.5%. However, the quality seemed to be better. So the numbers of reject was less by almost 20%. And also one other thing that really sort of amazed us, that the shelf life of the cucumbers, when they lie in the shop, it's about 20% longer than the other cucumbers. And in Olaf, they made a small hydroponic-like test with tomatoes. This girl, Malin, she took the seeds and took them from the very beginning up to 7 weeks. It seems that things are really happening here as well, because her thesis was that nothing will really happen. So there wouldn't be any difference. But the plant height, the stem width, and the internodal length, the length between the leaves, was significantly bigger in the tomato plants with processed water. And also, we found out that the vortex water tomato seems to be more stress tolerant, because she made an error in the first round. She took out the small plants into the big bio chamber when it was extremely light, and they got a light shock. But the plants with the vortex water seems to recover much quicker than the other one. And she concluded that, well, if you use VPT for preparation of the nutrient solutions, can affect tomato plants. So she had to change her mind, which was our victory for us. And however, this is a pioneer project that raises more questions than it actually answers. So there we are. Things are happening with watering the plants, and this is something that could be used for, say, irrigation, a more effective irrigation. We made a very quick field test in Captepera golf course in Mallorca, where the main conclusion was that we could save somewhere between 30 and 50% of the water used for the golf course, which is a lot. Another application where we use the subpressure mentioned, and you see how this one looks like. The other one is this one, used for other purposes. You see it looks slightly different. The reason is that we want to have another type of vortex inside. This should be more elongated, and it's for inline on the water line. This one could be used for shrimp and fish farming, for wastewater, and all in all, if you can maintain 90% of the oxygen saturation all the time, you will increase the yield with 5 times for shrimps, as an example. And wastewater, we have this system here. They're processing water from red beets, and it contains a lot of fat, and that water should be used for a biogas digester. So they want to get rid of the fat. The problem was that the fat have very, very small fat bubbles, and they want to get them away from the water. So we put this one into the water, and it bubbles up, and it lifts up all the fat bubbles so they can be skimmed off later on. This is a biobed, something called a bioblock. It consists of plastic tubes, formed like a net, and have a very high surface. And they put it into the water, let water come from beneath up, and they plant plants in it. This could actually take care of basically any kind of pollutant water. They have a plant in Malmö, at Alnarp, by the way, where they have black water from 50 persons coming. The only thing they do is have a pre-system where they actually take care of all the bigger parts, and the rest of it comes into this. And afterward, you can actually drink the water. You have only plants and the bacteria inside that take care of it. I've done it, I've survived. And you also get less swelling of filament bacteria in wastewater plants. Sometimes you have problem with bacteria that overgrows and fills the complete plant, and that tendency has gone down. You also have improved sedimentation. And of course, higher oxygen levels. We have a river project right now going on in Holland, in the River Dommel near Eindhoven, where we have a system with 10 of these connected in parallel, and they are put into the water. This is how it looks, and this guy is actually standing on this. We call it a skid. It's kind of a metal box. The reason is that when they have a lot of rain, it causes BOD, COD coming into the water, consuming the oxygen, and fish are dying, and the river stinks. So they want to prevent that. So in some strategical spots, they will have a couple of these systems. They will run like hell for a couple of days, and then will turn off the rest of the year, in order to prevent the oxygen levels to drop. So right now we are actually delivering a bigger system which will be able to put down 250 kilos of oxygen every hour down into the water, which is a lot. And this system is about 50% better, or use 50% lower energy compared to similar systems like propeller injectors and membrane aerators. Also, we have anti-algae. That was actually how it started. This is my pond in my home. And we have this little green problem here called algae. And I got tired to put up some 20 kilos of algae every third day during the summer. So I think I must do something about it. So this is the problem. And here is the solution. It's one of these small, you can see it is a red one there. I can see the bubbles. And this is after 3 weeks. No chemicals, just pump a little water. And the pumps can be wind-driven, so basically you can do it without any external energy. So the results here are wind-driven pumps, and no chemicals, no death of fish, and the ponds are more beautiful. And this actually also applied in the city of Malmö. We have a lot of them around in the municipal ponds. The next thing is crystallization. We found out in Malmö we have a lot of calcium in the water. And calcium have a tendency to clog on the sides of the pipes, calling lime scaling. And so we investigated that, and Johan went up to a university in the north, in Luleå, taking these beautiful pictures, where we can see the difference between ordinary tap water and vortex water, where we have put the sample between two polarized plates, and a code light and LED light beneath, and here is the sample. And if you twist one of the plates, you can see the crystal domains like this. As there's a clear difference. And I would like to show you also this and another phenomena where we actually freeze water. And this side is vortex water, and the other side here is tap water. Let's see if this works. Take some time. It's running. I have to synchronize them, and you can see what's happening here. Here we add the water. It's in the freezer. And look what's happened with the vortex water here. It freezes directly, almost. It freezes a little bit slower, but this one haven't started yet. And you wait, and you can see how the crystals are growing here. Very beautiful crystals. Look like feathers from a bird or something. And within a couple of seconds, you see how it starts here. It's about 45 seconds difference between them. Yeah. I think the camera doesn't like the minus 20 degrees temperature. I'm trying to focus. Watch out now. There. It freezes almost instantly. But it took a much longer time before it started to freeze. And this is probably because this water is subcooled. It goes below zero before it starts to freeze. Now, this is something we have used in another type of application called real ice. And this is how this one looks inside. And here is the preformer, here is the vortex chamber. And the geometry here is very, very important because the vortex have a certain speed when it comes into the vortex chamber, and then it goes out with a high rotational speed. And it is, because this opening is smaller than this one up here, and this curve is a way of controlling the acceleration of the vortex. We want to keep it in certain levels, because if we accelerate it too quickly, you will get expansion force, and you get loose of that contracting central string. So this is how the ice looks like, and this is how the system looks like. It's two systems. Basically, one system you put on the pipes, another system when you use and you spray out and you build up the ice from the beginning. And the results are, the ice is more durable, it freezes faster, as we saw earlier. It's faster to skate on. And that's a very interesting thing, because no one has really been able to tell me why is the ice slippery. We all have ideas. We all know that ice is slippery, but why? We all have ideas that the friction of the skate and the ice melts the water, or melts the ice to water, and you slide on a film of water. Also the pressures in the clone. But the equations and the models that describes this breaks down at minus 27 degrees Celsius. And people are skating and skiing in lower temperature than that. Thank you. So today, the idea is that you have a thin layer on the top of the ice with water that is not frozen and not liquid. It's kind of a gel-like structure. Now, do we recognize this? I think so. It is, for me, it's kind of easy water, a layer that lies on top that you slide on, like you step on a banana. And the idea is that we actually made this layer thicker or more stable or both. Also, you can save a lot of energy because the water is hot. In the machine, when you go out, the water is hot. You spread about 60 degrees water. That's the water to float out on the surface, go down into cracks and pores and heal the ice. But when we treat the water, it is, you can use tap cold water, meaning that you don't need to heat, say, 10 cubic meter of water from 10 to 60 degrees every day. That's a lot of energy. And also, the effect is double because then you don't need to remove that energy out from the ice afterwards. So, all in all, we have been testing this in Canada. The result is some of the best results are that we use 58% lesser energy compared to before. And that's a lot because a normal ice arena uses about 10,000 kilowatt hours per day. And my house uses 18,000 per year, so you can compare. And an ordinary small minor ice arena save up around 150,000 euro per year by lesser energy cost. More about crystallization, we can talk about snow. Here we tested a snow gun, or two snow guns. One was filled with water from a very big vortexer, and the other one was just ordinary water. They stood at the side of each other. We were testing the cloud, where the snow comes out, and this is the cloud from the vortex water, and this is how the cloud looks like from untreated water. This water is very, very wet, but here you can see the ice crystals. This is also an effect that the ice freezes much faster. And then we get into another crystallization process, namely cooling towers. Cooling tower is a big funnel with the tubes inside that should be cooled. You pump a lot of air, works fine in the winter, but in the summer when it's hot, you need to spray water on it. So, meaning if you have calcium in the water, the calcium will be stuck on the tubes, and a half a millimeter cuts away somewhere between 7 and 10% of the efficiency. Meaning that they use a lot of chemicals, a lot of acid, a lot of bacteria, antibacterial, a lot of anti-algae agents. So we made a system, call it a skid or cooling tower skid, where you have our small vortex here. It's a pump and some other filters and stuff. And you get basically chemically free blown-down water from it. So you fill it up, you run it for a while, and then you exchange the water. And the results here that we had been tested in Heineken Brewery in Holland. They ran it for 8 months without any chemicals at all. It worked perfectly. Normal operation works perfectly. So here we replace chemistry with physics. And fully implemented in the Heineken Brewery industries, they could save about some 350 million euro per year with reduced environmental costs. We've been testing further on in the US, where we found out that it is possible to save around 3,000 cubic meter per year and installed megawatt. Meaning that fully implemented in California, which have around 500,000 cooling towers, just this technique only should be able to save up somewhere between 7 and 8% of California's total water consumption. And that actually fulfills Governor Brown's norms, what he has said. And we have a small amount of energy saving because the system is always clean, so it's always running on full efficiency, more or less. We also found something we call strange field effects, which we really cannot explain. Maybe some of you will make it later on, but it makes it possible to grow without a fertilizer. It's something that Schauberger called the Earth Replicator. It is a glass egg. You dig it into the ground, so you have a little part of the top sticking up. You fill it up with rainwater, you cover it with plastics, and let the sun shine on it. Then there is some kind of energy emitting from that, so the plants grow better around it. And this is the result. Here you have actually the water generator, and here you have the other crops. And down here, these 5, they are 1.5 weeks old. And to the right, these 2 are 7 weeks old. So they can be compared. And you remember this effect? And this is how the field looks like. It's oriented in north-south direction, about 7 to 8 meters in this direction, about 3 to 4 meters in that direction. And I can't explain why, but the observation is there. We have done it many times. IAT tested it for 42 different places, and it works. And if you want to, you can get the recipe on how to do it later on. So, to end up, the expected effects on water, I measured subpressure for the various application, altered crystallization behavior. We also found that we had altered properties of the water, such as wetting ability, the water's ability to wet surface. That's an interaction between the surface and the water, which we use in the ice. We found that the viscosity goes down somewhere between 3 and 17%. We have better soil penetration, we have better solubility, so the tendency to dissolve things increases as well. We have an increased heat transfer, so the water and ice transports heat and light better. Increased heat capacity, that's interesting. So the water capacity to store energy increases with about up to 10%. And I thought heat capacity was not constant. Separation effects, as we have seen, and also these strange field effects. This is what we have found so far that we are actually using. So that's the sort of summing up of my findings. And this is beautiful pictures when we show the center string inside a tornado, inside one of our tubes. And it's this little transparent device. You can actually see the bubbles in the center of the vortex. So I want to make a final commercial for IET. We have next year, in the beginning of my first weekend in August, I will need 2017. And you can look on this webpage to see when it's coming. You will see the information coming around the end of January, I think. And finally, I would like to add this person to some of the water heroes. This is Mr. Olaf Alexandersson with his spiral tube, explaining things for us. He's today 97 years old. He's still strong and fit, but his memory lasts for about 2 minutes. So we have forgotten everything, sadly. But that's how it is. He's 97, so I guess he would be allowed to have us. Thank you all.
Thank you very much, Curt, for this very impressive demonstration of the possibilities of what you can do with that. I wonder what happens if you tie that technology up with Jerry's, or better, Kurt Kung's water separation based on Nafion.
Oh,
so
yes.
I leave this up for discussion. But anyway, we have a couple of minutes left for questions. Go ahead, please. Jerry.
Well, you mentioned easy water as somehow possibly being connected with the vortex. And one thing occurred to me is you mentioned also when the vortex is created, there's a huge exchange with oxygen. Well, we studied the effect of oxygen, added oxygen on EZ formation. And the reason we studied it was actually for understanding hyperbaric oxygen therapy. And we found, we just published a year ago, that if you add oxygen, you get bigger EZ or easier EZ formation. So So it kind of fits. And do you think that the inner edge of the vortex consists of easy water? Because that might explain why the coffee particles are gathered in the center, because the easy is an exclusion zone and excludes. Is that somewhere headed on the right track?
Yes, that's one of my ideas actually. If you see the vortex from above, you make a cut section, you don't have an ordinary field, you have kind of a spiraling field. And in between these layers, I think easy water is sort of generated, and it squeezes it together towards the center. That's why we always want to have these contraction forces, because otherwise you have expansion. That's not good.
Yeah.
And also that's is a possible explanation to why the ice freezes faster, because you add actually easy water to the water, which means that this water is sort of prepared for freezing.
Right. Yeah, thank you. That fits.
Yeah. Okay, we got another question over there, please. Microphone, switch on the microphone, please.
Yeah. Okay. You said that the savings in using this water for resurfacing ice is 58% energy savings. If the ice layers are stronger, and you might be able to make each session last longer, or you might be able to do less surfacing, and you might save more than 58%.
Well, not 58%, but you might save water, indeed, certainly. And this is about, we're just looking on the energy, because energy is a big issue while maintaining and making artificial ice. Yeah. Water, yes, it is more important, but I think it's more important when you use it in cooling tower and other irrigation and stuff. I think in California, you have about 75% of the water uses is coming from the agricultural industry. So if you could reduce that to, say, 50%, that's a huge amount of water.
Well, I was thinking specifically of the application of running the Zambonis.
Sorry, I didn't hear.
Running the Zambonis. You could run them less often, or they could need to run less. You know,
They can, yes. Because as the ice freezes much faster, you don't need to run that slowly anymore. You can actually go on. But there is also a limit how fast they can run on the ice, because the ice is slippery. Okay. So yeah, they can do it faster and sort of better results as well.